Welcome to Playing with Inference, a podcast where we dive into the intersection of Gen AI and games with folks building in the space to try and move past the hype and have real conversations. In this episode, we sat down to talk about the definition of AI native game, something we've used before on the podcast and we've seen more folks use it out in the discourse. What do we actually mean when we say that? What are the bounds of an AI native game? As you might imagine, the conversation went long, but it divided neatly into two clear sections. First, in this episode, we'll talk about that definition in detail, a little bit more about the technical or philosophical lines involved, and come to a conclusion. Then, our second episode next week will dive into what are the practical examples and market trends of that definition, and how do we see it evolving with what folks are actually building. Before we dive in, just two quick callouts. First, with any topic that tries to define a thing, I imagine you also have opinions or maybe frustrated that we didn't include or exclude something. Please comment or reach out via our Discord or any of our video comment areas, any way, email, and bring it up. We have no illusions that we were comprehensive and are sure we have blind spots. We want to hear your opinions and what we missed so that we can go and explore those and update our definition. This is a really vibrant space. We're really excited about it, and we want to learn more. We're very deeply curious. Second, we'll be hosting some events during the upcoming San Francisco and LA Tech Weeks to meet more builders and enthusiasts in the space and just go on that journey of learning more. Keep an eye out for those events, and they will be great places for you to come up, meet us, and tell us all the things that we're getting wrong in the podcast. We're really excited to do this and hope to see you there. Now, let's jump into the discussion.
As you can probably infer, we are super excited about the role that generative AI has in gaming. So today we want to talk more about what we see Gen AI brings to the table and what actually counts as a AI native game. Basically, what are the new experiences that are possible only because of Gen AI?
Yeah, I've been wanting to have this conversation for a while because what's better than arguing over definitions and names of things? But in preparation for this, I thought, okay, this will be easy. Like, we'll just go ahead and write down a couple of ideas of what we think AI native games are. We'll be fine. And then I started doing more research, and like, stuff is moving very fast. Like, even I try to stay on top of this, and there is a lot happening. So I think it both makes the idea of trying to decide what is an AI native game worthwhile, but also maybe challenges what that definition is, because it could be evolving pretty quickly. But yeah, we say we're doing Playing with Inference, right? We're talking about AI native games, something like that, right? Games that use AI, games that use machine learning. So let's just try to pin down what it is that we're really talking about here. And when we were prepping for it, Ramon, you had an interesting definition to start with that I liked. So why don't we just dive in on that?
Is that the infinite dev artist?
Yes, yeah. Let's start with that.
Yeah, so basically, the way I've used it when talking to our tech designer and trying to hire him, the way I defined it was, listen, we're interested in making games where even if you had an infinite amount of game developers, artists, what have you, whatever profession, you couldn't make that game. So we're talking about something that is genuinely novel, not about like a novel capability, not like an abundance of a specific resource. I don't know if that's a way, maybe the way that I framed it in the beginning, it makes more sense. But basically it's like, at what point does this actually enable things that it doesn't matter how many manpower you have, you couldn't do it? And
yeah, I agree. When Carl and I were starting with JMT, one of the things, when we started to explore this particular avenue, one of the questions was, what is it? The question we went out to wanted to answer was, can we do anything new, like truly novel, that we couldn't have done before? And then, is that novel thing actually interesting or fun? Those are two separate questions. But what I wasn't interested in doing was just using machine learning or generative AI because we could, right? It needed to bring something new to the table. I kept reminding myself that we've had a bunch of different tools over at this point, literally generations of game developers that we use to create games. This is a new tool. What does it add to this repertoire, right? What new things can I do because of it? Just because it can replace a particular tool doesn't mean it should if it doesn't have a certain kind of return on investment, right? It needs to make it better in some way or create something that's new.
It also has to be new in the eyes of the player, because one of the things that I learned on the early part is like when you're building it. So, for example, I was building this social deception game, Zarnova, where you have to fool the other characters that you yourself are a human, right? Sorry, you yourself are an AI. A lot of the systems that I implemented are hidden from the player's view, or are not explicitly called out. And for me, it was very fun. It was because I'm building that. It's something interesting. But from the player's perspective, I don't know if that's something like if that gets added, or if I'm playing, how to say, we also build a you go into a victim's dream and you have to figure out their password based on their dreams. So we were generating quests and scenes on the fly, but we could have generated 1 million rooms and it would have been the same impression, right? Like the process of generating that content was novel. The way we were doing it was novel. It couldn't be done in that way before, but for the player's eyes, maybe it wasn't a genuinely new experience.
Okay, so this, we're getting right into the heart of it a couple of different ways, right?
Yeah.
Okay, so we could say if we want to say what is an AI native game, and I want to know, we're going to come back to this of, does that definition matter? Like, what does an AI native game mean in the genre? But let's just say we're going to look at a game and decide, is this AI native or not? We could talk about, under the hood, does it use machine learning, right? Does it just use machine learning and generative AI somewhere in the mix, right? That could be one criteria.
Yeah.
In which case, for example, I would go back to say, does Black and White count as an AI native game? You're saying yes, it does, or yes?
So yes to your statement, and yes, I think it counts, right? Like, I think a game where you have an RL algorithm in the loop sounds as AI as you can get, right?
which I would say, like Black and White, I loved that game, and I would add it as one of the inspiration for me as a gamer and a developer in games. And I think there are many of us, this game comes up in conversations with folks in our space quite regularly. Okay, but there's another point, and Black and White might count across all of our definitions. We might use this one because, to your point is, but what's the player experience? Because there's another part where, like, how in your face does the AI need to be, right? So if you built a new experience, but the player didn't, because there's two ways to look at it. If you build a new experience, it's, wow, we used the tech in a way that we couldn't have done before, but maybe from the player, it's not as apparent to them, then does it meet the bar? And I say there's maybe two aspects of it. One is, you might be able to do something that's truly novel, could not have been done, but maybe the state of the art was so good that a player didn't notice anyways.
Yes.
Baldur's Gate 3 has so many different endings that at what point did you go, we have 1,000 endings, to be, we have 10,000 endings or 1 million endings? Like, at what point does a player, I don't know, does it matter? Maybe it doesn't.
I think that's a great point, because so I was thinking about this. I think not only do you need, so in Baldur's Gate, or like even like way back when Chrono Trigger, like you have all of these endings. There's a number after which it doesn't matter anymore how many more endings there are, right? As long as it feels like it corresponds to the player's actions, you could have used AGI, or you could have used a crap ton of writers doing meticulous handcrafted work. For the player's perspective, it may have not done a big difference. However, I think the speed at which, so here we're going into details, the speed at which the player's actions reflect on the narrative and the breadth with which that happens, I think is where you start seeing a difference. So you can't explore, for a game as big as Baldur's Gate, you can't explore every single ending, or there's like a small finite number after which it doesn't matter, the marginal ending doesn't matter.
Yeah, but like when I went through my run of Baldur's Gate, I've only done, I technically still haven't finished. I'm sitting in Act 3, almost done, because I got a little bit more to do. But I did a Dark Urge run, and immediately in Act 1, spoilers a little bit, like you have to make some moral choices around who you align with. And there were lots of, like, if I were sitting at a tabletop, there are ways I could try to solve that problem that were not available to me in the digital experience. You could try to negotiate something. You could try to decide to betray this person or that person.
Yes.
And now I don't know. So this gets to, like, we might be narrowing it, because is player agency a specific type of, not all AI native games need to maximize player agency or simulation agency potentially. Like, you could apply machine learning in lots of different ways that may or may not be maximizing player agency.
So I actually like this example of using, the way I wrote here is like creative action, like the breadth of what you can actually do, or player agency as you're framing it, as something that's important. Like, so when you're talking about the tabletop versus your Dark Urge run in Baldur's Gate, what were on Act 1? What would you want to have been doing, or what are the options available on the tabletop, or that would be available on the tabletop, like more specifically?
Well, sorry, did you have more you're going to say there?
No, I'm just curious because I want to...
Okay. So if you look at tabletop role-playing games, which again, like, I am heavily invested. In fact, actually, a couple of these just won Emmy awards last night. So anyways, if you go way back, it's funny, but there's this line in one of the very early war games in the 1800s, actually, which, if you pull back the history of role-playing games, where it has this little phrase that I love, which is basically like, the player like, anything may be attempted. Right? Doesn't mean it's a good idea for the player to attempt it on the table or anything else, but the concept that because you have a referee at the game, these like early war games, right? And the idea is that you have, therefore, a human who can make judgment calls in the moment that go above and beyond whatever the rules are at the time. So the player may attempt to try to do almost anything, and it gets interpreted. And this is one of the ways that tabletop role-playing games, if you think about the canonical experience of a new player in one of these games, the stereotype is that they start to play and they're like, what can I do? And the dungeon master, game master is like, you can do anything, right? And so this form of tactical agency, tactical choices that they can make almost any choice and it gets interpreted, is a hallmark of that type of game design. There's a similar concept that particularly at JM&T we look at, of what we think this brings to the table. We look at it through, one, the lens of narrative control. So not merely player agency, but who has control over the narrative at any given time. And traditionally, we only have two. We talked about this in another podcast. Like, we only have two agent entities involved, the designer and the player, right? And so you have like sandbox games, which let the players interact in a simulation and they have more agency, versus a game that has the designer has more, it's more on the rails. But now you have this third entity, the AI, that can interpolate between these. And at what point does the AI have agency, or how do you use that AI to maximize or change the agency of the others? So we look at that as, at JM&T, we talk about that as narrative control. But I think if we talk from a game design principles perspective, I would say, and I'm going to get a little theoretical here, but what does it really do? If someone asks me, like, what can you do that you couldn't do before? I again pull from the tabletop space. We get rulings over rules. So before, you just had rules. It has to be executed. You don't really get a choice of the rule. You can add randomization, you can add heuristics, but in the end, it is a set of rules. Whereas rulings add this sense of a judgment call. And in fact, if we were really to push it, it's almost like the boundary of computability. We're edging into this like non-computable portion that we add in. And there's definitely an argument here, because we are using machine learning to compute this, but it's this kind of non-computability that we look at in complex adaptive systems and complexity science, of we have to let the system run to figure out what happens. You couldn't compute it ahead of time. You get this kind of edge of computability boundary, which is something we arguably is new that comes to the table that we did not have before.
So I like this rule over rulings and what you were saying earlier about the player agency, because I think it plays very well to some things that I was thinking about. Like, first, when you were talking about Baldur's Gate and the mini endings, I feel like one of the big differences between the tabletop experiences that you're talking about and Baldur's Gate is that your actions are much more discrete in Baldur's Gate, and how the game reacts is less flexible, or it has less of an immediacy of showing this, like whatever you do has direct consequence in this breadth of what the consequences are versus what can happen in the tabletop. And is this immediacy of it's so close to the core loop that I think is where the difference becomes. And here's like where AI dungeon or AI dungeon-like games really shine, right? Because you have this referee in the game, you can get interpreted actions, which takes into the other part of the rulings over rules. I think one of the core motivations of machine learning is that, or has been that, instead of handcrafting rules by hand, we were like, okay, what if instead of me telling you, computer, every single rule and how to behave at every step point, what if I instead show you how things should behave and you come up with whatever underlying rules you think are proper to make that work? And this feels to me very much on the rulings over rules. You're essentially saying, I'm going to show you how I think this game ought to be, and you get to to make the calls. But the process of you've trained this model to make those calls in the first place.
Okay, so we're gonna rabbit hole just a bit because we need to, I think, come back up to the AI native game definition. But I had to double check it. The term I was looking for, so there are a couple terms in here, and I want to call out on tabletop role-playing game design. So I've talked about narrative agency. We've talked a little bit about player agency. The term I was also looking for, and it comes from the Alexandrian, which is an exceptional blog on tabletop role-playing game design, and he has a book out that's really good too, called Tactical Infinity.
Okay.
Right, which is basically, again, this kind of concept of anything the players can attempt any action. Now, that's attempt. So what's noted is that the player is an entity that is independent from the simulation, right? They are controller of the simulation, and they express an intent. That intent can be any attempt, anything they want to do. I'm going to try to convince the dragon to go and have a tea party with me rather than rampage over the village. And that kind of absurdity, though, is very stereotypical of the kind of narrative freedom that someone can say in a tabletop role playing. They'd be like, you could try, I probably won't work. And then you have some way of translating and interpreting that into the game simulation. So a true tabletop role-playing game, as opposed to just a mere round-robin storytelling, collaborative storytelling, there is some mechanics that we say, you don't just get to say what happens, right? That's narrative control. You don't get to, if you're doing like a round-robin like storytelling or even some type of improv, you have narrative control. You can take it any way you want. If you're like, yes, and the dragon has a tea party, we just go with it. So what makes tabletop role-playing games a game as opposed to improv is that there is a set of rules that help translate when you get that narrative control to say what happens, when your intent binds the narrative. And most of them not only just have a rule, but because it's a tabletop experience and those rules get interpreted through a human and often a referee in order to provide some consistency, though not all have referees. So the argument would be that we can do that now in a video game experience where what we do is we can, one, write these rules in an English language, and two, we can try to take the narrative game state and put that in a context. So now we have this kind of latent space that we have that is like the narrative space, the simulation space. And then we try to interpret how the narrative should change by running through inference that applies the narrative rules through English, which again, in the form of a machine learning, what we're doing is we're saying we're going to basically push these, like the English math of, we have a narrative here, we want to apply this transformation to the narrative by these rulings. What should be the resulting narrative? And
here you're talking about a bit closer to like how common law works, in that there's this rules, but they get interpreted by a judge who makes the final call, versus like in civil law or Roman law, as we call it, whereas like this is prescriptive and the judge's work is just saying like checking marks and saying, okay, does this fit all of these things? Right. And what you're saying is we're letting the AI be the judge, but we get to write the rules. Like we're just this legislative body that gets to write the rules, but in the end, we're handing off the actual rulings to the AI.
Correct. That, and I think that's and you could do that at multiple layers of the game simulation.
Yes.
Right? You could do it, and in fact, in Retail Mage, we do this, for example. Like, you could do it down to the level of, am I strong enough to pick this thing up? Yes or no? Which in a traditional video game, you would just do a simple calculation, like, obviously. Like, you have a strength, this thing has a weight, you have some calculation to determine, can you pick this thing up or not, right? So you could do it down at that layer, all the way up to, what should the next quest be? Or what is the next line of dialogue? Or what is the next major story beat? Or any other kind of, what is the level? How is it laid out? What color are things? You can ask any of these questions. And you can use different machine learning systems, not just language ones, to generate the next bit of content that you want to present.
So here, are you trying, so coming back to the overarching definition arguments, would the statement be, or would the argument be that it's the narrative control, the player agency that makes it an AI native, or these, or is this like fuzziness in the rule set or fuzziness on the rulings?
I don't know. I think honestly, we're honestly talking about one type of AI native game. So I would say we could divide it in terms of, there's a like more deconstructivist definition that would just be like, do you have a neural network somewhere in the game loop? Do you have machine learning as a meaningful part of the runtime execution? If so, you probably count as an AI native game in some way, right? That is like the minimum bar of something. And then the next questions then tends to be about the magnitude of the impact in the player experience, right? And that magnitude could go in a bunch of different ways. As we pointed, like it could have narrative impacts, but it could have other kinds of gameplay impacts in terms of the like choices presented in front of a player, or the way that the AI NPC responds, or then we get into UGC. Can the player directly interact with the simulation, is it like, am I vibe coding the game with them in some way? Does UGC move to almost a vibe coding enhancement that I'm able to change a program or mod the game at the same time? And then the final ultimate expression might be what people anticipate of, do we get some type of world model where the entire game is a machine learning simulation, like an interactive Google VO3?
So I think there has to be the two things, right? Like the checklist of, is there an AI or ML running in the loop? That's a requirement. Otherwise, if you have a very fancy if this then that rule set, I guess in the 90s you could have called that AI, but not anymore. But then there's also, does this change meaningfully what the player experiences? It's in a way that what they actually perceive and experience is different from otherwise. Because you can take to the extreme these world models, and if all they're doing is generating a Counter-Strike replica or a Minecraft replica, but with shittier consistency, or let's say they recreate Minecraft for whatever reason, right? If they're just generating the exact same experience, but by going through a crap ton of GPUs, I don't know if I would call that AI native, because in the end, in the eyes of the player, that doesn't seem like AI at all, unless for the weird artifacts. That's just Minecraft.
Yeah, that's a good point. That's why I think like it's interesting to look at the kind of components. Like there's the, do you use the technology, and your earlier point was interesting too. Can you do does it use this technology in a way to make something that could not have been made before? So if all you did was just make more 3D assets, even if they're arguably so if you just made more 3D assets, then if we did that before, is that AI native in some way? Does it pass that bar? Now, if it made those AI assets in real time in a way that existing procedural generation systems, like even something like Spore, like whatever, or Dwarf Fortress or anything, like could not have done before, then you're like, okay, now you've cleared some other part of the definition.
So it's funny because I feel like procedural generation is very much in the same family as machine learning. So like the only difference again to the rules is that procedure generator ProcGen has handcrafted generation rules, and ML or GenAI has learned generation rules, right?
This gets to the other. I think we can have a very fun, debatable conversation in the game industry that other industries, the few can have, but the game in particular, because it's not like we haven't had something we've called AI for a long time. In fact, this is why I sometimes struggle with it, because it's maybe we have like classical AI, and then we have, I don't know, machine learning. Because I use the term machine learning so often because it involves AI in a way that is specific to the generative models that we have today, the neural network models, as opposed to other types of AI that we've developed in the past in the game industry. And procedural generation is also in that category. And how could you have an AI native game that doesn't have a neural network in it?
That's a fantastic question. Because so part of the problem is that what counts as AI has been moving with time. Like people wouldn't call like support vector machines AI anymore, and they said certainly the AI research community wouldn't call GOP or symbolic planning any sort of AI, despite the people who still do research in that areas. That's very much in the AI tradition, right? That's you know.
In the end, we're probably going to agree that there's some sort of definition that's you know it when you see it. But I do think that the combination of what is the technology underneath and what is the player experience are two key points that we've had. I want to go back to because I want to go to the what does this matter? Okay, like we have this whole podcast around this, and obviously we're like, AI native games, this thing matters, but because it's not necessarily a genre, right? Is it like mobile native games? Is that the kind of thing we're talking about here?
I think it's weird because it's not a genre, it's not a platform. I think it's a family of games, or it's a family of genres, maybe, or it's a technology that allows new genres to be made. The way I normally phrase it is a little bit like computer, like 3D graphics or the internet, and the impact that it had in games.
Like online games.
Exactly.
But service games or something.
There are games that pre-broadband, they couldn't exist. There were entire genres that would not exist before broadband. Now everybody has broadband. That's like a technology that enables all types of genres by playing with friends. I think it's similar. You could even say the same with ProcGen and ML, right? Like maybe ProcGen is like dial-up internet, and then ML is just the broadband equivalent. And the jump in quality and breadth and all of this does enable a lot of different genres. It's not a platform per se. It's not a new distribution channel. It's not a specific genre. It's a technology that enables like a family of genres. That's how I normally see it.
What about the argument that it is not merely a genre, but potentially pushing into a new medium, or some of these genres push into mediums? And when we say medium, I'm thinking more video games versus film versus like an entertainment medium.
I think the problem with that is that video game called dibs on the most broadly defined of all mediums, like interactive video, audiovisual media. That we're missing what, 2 senses? Like, it's like, okay, like what are we not covering?
Video games got in there early, and they're like, this is all video games. It's just all video games. It doesn't matter. The holodeck is a video game. Basically, the only reason
life is a video game. Everything is a video game. Okay. So I think it's a bit hard, I guess, because if there's that broad view of video games, and then there's the more narrow traditionalist views of mobile game, casual mobile maybe doesn't count as a video game. At the beginning, I feel like it was a little bit like that. I think now it's well admitted as in the video game family. So it's I don't know if it's a new medium. I think, again, I keep thinking like I think we'll see new genres big enough to start calling them their own things. I think it's already. We brought this a bunch of times on the podcast, but it's evident that there's a core human itch in the waifus and husbandos type of apps. I would call that a video game, but it clearly being secluded into their own thing, right?
So this gets us to an interesting point of talking about, like, all right, so we had this kind of definition. We talk about the impact. I think we're starting to circle around some things, but if we go to that, what's the impact on the industry and so there's two parts I want to explore here. One is we can look at this idea of AI native games. To your point of it's a new kind of technology like broadband, and it's that like there's games that wouldn't have been made before that now can be, or there's new types of GPUs or whatever that lets us create games that we didn't quite make before or created in an earlier form. Okay, so then the question is, what are those games? We could look at those games and be like, hey, that's the impact to the industry, and we can start to say, does it count as AI native? And one of the ones that I wanted to bring up was, is character AI and a AI native game or not? Does that count?
I vote yes.
You vote yes.
Yes.
It's a game. It's a game.
Yeah.
Now we might get into that, like what's a game definition, which is there are literally like philosophical treaties on this. I
think if you count AI Dungeon as a game, I would call character AI as a game. Maybe the players of character AI won't count it as a game. Like they will think.
I won't deny it's a form of entertainment.
I would argue that most users of character AI would call it entertainment. I don't think all of them would agree. I think there's a reasonable chunk out there that would genuinely think that they are having some parasocial relationship.
They're like, don't you call my waifu an entertainment?
Exactly, right? It's like, what? So Tinder is a game as well, which is true. Tinder is a game.
Okay. All right. So it's interesting. From your perspective, character AI, if we count AI Dungeon as a game, we almost have to count character AI.
Yes, that's my feeling. Like, it's basically a very similar experience, and it's almost like the lore or the fantasy that you're playing is the main difference. Like, one caters to human relationships and dating, and the other one is to like slaying dragons.
I think if we want to dive into this anymore, we would end up having to argue a bit about or debate about the definition of a game.
Yeah.
But I think we are seeing so what are we seeing right now? Like it's interesting because you can see parallels in the game industry of other times when a new technology is adopted, whether it's mobile, whether it's online, whether it's VR, right? Like you get at least two things happening quickly. You get the let's immediately try to translate what we had before and move it in, right? Yes. So I have a radio show. I'm going to put the radio show on television now. And then you get like the first early what is native in this environment, like as quickly as we can. It'd be Doodle Jump or something like that. Wasn't that what's called? Like very early, we have an accelerometer. Let's see what we can do with this. So we could argue that character AI and AI Dungeon are examples of like the first, let's see what we can do with this technology. AI Dungeon clearly is that arguably a really great example of pioneering and pushing like almost too early, like their first attempts. We're going to try to do this even if it doesn't quite work, and then we're going to keep iterating until they got a really more compelling platform over the number of years. They were very early in that space.
I think, so quick tangent, I think whatever definition we come up with, I think AI Dungeon has to be, if not the first, one of the first modern Gen AI or modern AI native games, right? If we land on a definition that calls Black and White an AI native game, I would call it like a pre-modern AI native game, say, as in, like they would call Prussia, pre-modern army or whatever, right? There's traces already of what was to come, but
so we should digress on this a little then, is because there are times when I wonder, like, where does Alien Isolation, where does Fear, where does Dwarf Fortress sit in this? Because there are aspects to what these games are able to do from and there's others we could look at. Even if we want to look at natural language processing, we could look at like Scribblenauts, right?
Yeah. I think Scribble is another very in the line type of game.
Right. Okay. So at minimum, these are precursors.
Yes.
And depending on the definition, they are like early stage or because even if they aren't necessarily using neural networks, I think if of our two definitions, or two parts of the definition, like what technology you're using and what's the player experience, they certainly allow for some of the player experience or hint at that player experience.
They definitely do the player experience part. I think it's not the neural network that matters, it's did they handcraft every single rule, or did they show examples or rewards and those rules happen to be learned by some sort of algorithm doesn't need to be gradient descent, but
Well,
it can be like some sort of automated process to learn the rules.
Yes, because there's a couple. You could even look at Spore or The Sims, right? You get emergent behavior, and that's another point: is complex adaptive systems, cellular automata. Cellular automata are examples where we don't have machine learning, right? We don't have this complex neural network, but we through simple rules get emergent behavior, right? And so there's somewhere in there that we've been playing around with this both in AI life and AI artificial intelligence and simulation, both in academics and in games for a long time. And I think that if they aren't included in an AI native game, they're like within the broader sphere of this kind of space. Again, I think that then you look at what's the magnitude of how that was used in the particular entertainment experience and what was the result as the player experienced it. Like how much did it contribute to the experience itself?
I just think so. Drilling on that cellular automata, and at some point we have to come back to what you were saying before.
Yeah, we need to go on to the types of games.
Yeah, but I think in cellular automata, again, the rules themselves were handcrafted, and what emerged came from those rules. What I'm trying to drill back is like the rules themselves were learned or automated, auto-generated versus handcrafted, and I think that's where on the technical side, not on the player experience side, but on the technical side, that's more or less where I would draw the line.
Explain a little bit more, because I want to dive on that just a bit more.
In a lot of this emergent behavior or emergence, or this type of games where you're trying to get some sort of emergence, like in cellular automata, normally what you have is like you handcraft a bunch of small rules, and the way they interact with each other gives the whole quote unquote organism a behavior that is not evident when you were crafting those rules, right? There's this greater thing in the interaction of a lot of these small rules. And I think that's something that we've used for a lot of different experiences. I think the main thing that makes that not a AI native experience is that those rules were crafted by someone. And the reason why I'm saying like the rules have to be learned by some method, not necessarily neural network, not necessarily gradient descent, is that, or actually the rules have to be generated in some sort of automatic way, is you could imagine some sort of system where you come up with random rules. So you generate random rules, and we can think of what that generation function is. And the way you learn which rules you want is you put that in front of people and they say yes, no on the emergent behavior. So nobody's actually picking the individual rules, but you have some sort of evolutionary process where the rules that are favored by the people, by how they interact and how the emergent behavior looks like, is what gets chosen. I would consider that already on the AI line, because it's an automated process for learning these rules. And that's where I think it's, again, going back to what's the main motivation for machine learning, is that I don't want to handcraft each individual rules. I just want to tell you what is good and what is bad.
See, I think there's an interesting conversation to have here. I think, though, I'm not sure I always agree, because I don't know if it's about the rules themselves, but how the computation is applied to the simulation, right? Because the rule itself may or may not be written by a human. Okay. I'm not sure that the rule has to be hit. The question is about the compute. Like when we look at a neural network, the question is the computability of the neural network is that you cannot get from one end of the net. Someone from machine learning might completely destroy me in comments later, so I'm interested. But one way to think about it is it's about the computability. I can't go if I remove layers of the network, I don't get from A to B the same way. Right? There's this kind of computability. I have to, like, same with complex adaptive systems. Like, you have to move through each step to get to the computability. I can't create a shortcut to compute the answer, right, of other type of computability systems. If we're talking about a simulation where, like, I can look at step N, it's deterministic, right? How deterministic is the system? I can look at step N of the system and I can determine that on a time kind of horizon. And other computability systems, like, you can't predict where we're going to be at time N without walking our way through each of those steps, right? Says something about the complex as a system.
Oh, okay. Sorry. So you're talking about like you can't. There's no closed form solution to like the process that you're going through. You have to go. You have to run forward the simulations.
Yes.
A little bit like I think in physics, the example would be like turbulence. Like you can't say
Right.
with a clean formula where you're going to be at time t equals 100. You have to play the simulation.
And in video games, I would say like there is something about AI native games that now, I want to call out. There are other games that do this, right? You have deterministic games, and it's always not necessarily the same of, okay, we just had a random number. In fact, a lot of times there are games that are unintentionally have this characteristic, and game developers will intentionally put determinism back in so that they can rerun tests. So they like, okay, we're going to make sure that we seed every single random number generator appropriately. Like there's a whole art in this in game development of allowing for a probabilistic outcome because we have random numbers involved, but we have a determinism so that if I start from the same seeds, I start from the same clock, I can rerun the simulation back and forward. The question would be, is an AI native game have a characteristic where that cannot be true because of the way a machine learning, like it's too sensitive to internal controls. Now, we could talk about whether temperature makes a difference, and then we get determination. I don't know. Maybe I'm thinking out loud here a little bit, but I'm wondering how much of this is part of it, because
I don't think so, because if you look at how these models are sampled, we're still relying on if you seed the model, you're going to get deterministic behavior, right? Like you're going to get the same, for the same input, the same outputs. It's the model themselves use a random number generator at the last step to choose what token they want. And we're talking about, like in this case, transformers or language models. But for the most part, where this randomness comes from is because you get this probability distribution, or like this weight, let's not call it probability, this weights on what are the options that you're going to choose. This is why I think this sounds so much like procedural generation. You get like these options of what you get to spit out next. And then you throw a dice, or sorry, you flip a many-faced coin, and then you choose which one based on the weight.
Okay. Then,
so that
maybe
flipping of the coin,
maybe I'm even like tearing down some of my earlier definition, because the question is then that what machine learning lets us really do, that it's maybe we're being too generous by saying that we really truly get, like, this is AGI, how far are we along? Like, we're being maybe a little too generous to say we truly get fully, maybe not even human level judgments, like something that's more akin to human level judgments. The question is maybe that what we're doing is the magnitude of inputs has changed in a significant, like in a machine learning system, in theory, what I'm able to do is take into account many more parameters in order to do that computation that I would not have done in any particularly handwritten way of saying, I'm going to take, because the idea in a machine learning system is I can take this like big, massive amount of input data, like particularly when I'm training, I'm like, I get the whole simulation, I get this whole book, I get all of these things. And through the machine learning training process, I determine, particularly with transformers, what to pay attention to what degree, everything else that I just never would have handwritten when I'm writing a procedural generation system. Like I'm going to, like the number of things I take into account when I'm trying to use a procedural generation system to determine, okay, how I'm going to decide, does a chair go here? What's the next thing that we want to do? It's at a human scale of the number of things I'm thinking about, even with a team or organization. And part of what's happening in a machine learning system is I'm able to take a number of parameters, some of which may or may not even have a significant weight, but I'm doing so in a way that a human never would.
So,
or certainly not right at the moment. Sorry. Human never would in terms of how they would have written the system in the game mechanics.
So that's why I think I keep going to this, like how you wrote the rules is what counts in the technical side. Because if I want to craft the behavior of a dog, there's so many little peculiarities of, okay, when does it raise the tail? When does it channel? When does it do, like, when does it fall asleep? That it would take me forever to handcraft each rule of what happens. But if I wanted, so instead what I can do is I can show a lot of examples of how dogs behave. And at least from our perception, it's going to look and feel very much like a dog, even if for some weird auto-generated set of underlying rules that we never fully understand how they're working. But from our perception, we get that closed behavior that we wanted. And it's that inversion of the, when you're doing something procedurally, you come up with rules, you see what you got, and then you go back and you
do like a search over a space or.
Yeah, exactly. And here, instead of, what, I know when I see it. Now let me throw it into NVIDIA's GPUs, and then can you please come up with rules that make it happen, or that make it like that?
I'm just imagining listening back to this podcast later and being like, I'll understand our argument so much better now that we think, because the argument there a little bit is like, what we're really talking about is that's what machine learning is, right? And you're saying like, look, So we go back to, we're looking at what an AI native game is. Machine learning is a fundamentally different type of way of processing data, both in terms of how you create the model and what the model can do. And that distinguishes it from prior attempts of procedural generation, even though they are related, they are cousins to one another in some way.
Yes.
But the inherent difference in what a machine learning neural network can do, what we've learned, if we make it big enough, if we push enough data in, if we refine it enough, creates a qualitative difference in what the system is capable of, a machine learning based system versus a prior procedural generation based system.
Yes.
And so then an AI native game has to include that technology in some way and has to then therefore leverage that technology to create a better player experience that is only possible because of the inherent capabilities of the model.
That would be my stance.
Okay. That only took 40 minutes to get back to where we were.
It could have been an email.
For listening to the full episode. We really hope you enjoyed the discussion. It would help us out a ton if you subscribe to the show on your platform of choice, as well as shared it with folks you think would find it useful. You can always check out playingwithinference.com to get in contact with us, join our Discord, or just find the links to the episodes. See you next week.